Okay, so we have solved this question in which this was the equation x square minus x, and then the remaining equation. So we solved it by the reduction of order method. Okay, and then you can see that we have performed this much long calculation. However, there is a shorter way of doing this type of question. So for this, let me do it again. We can use a formula. Okay, so reduction. So this is the so reduction of order method by formula. So what is the formula? The formula for this is we calculate a function u, and which is equal to 1 over y1 square times e to the power integral of function p into dx. Okay, so what is this function p? Let me write it a little bit neatly. P into dx. Okay, so what is this function p? Function p is, for example, if you have this equation, second order equation, y prime plus px into y prime plus qx is equal to times y is equal to 0. So px into y prime, so y double prime plus px into y prime plus qx into y. So we take this function p from here, and then we find the value of u. So u is equal to the integral of u times dx, and then the second solution is y2 is equal to u times y1. Okay, so let's show it by this same differential equation which we solved by the long method before. So this was the differential equation. So this differential equation needs to be put into the standard form like this. So then it will be x over x square minus x, y prime plus y, that is 1 over x square minus x, y is equal to 0. So in this case now the function p is x over x square minus 1, so which simplifies into 1 over x minus 1. So function simplifies to 1 over x minus 1, then we can find u. So u is be 1 over y1 square, and then for this differential equation we know that y1 was equal to x. So it will be x square e power minus integral of p. So p is actually minus here, minus. So this minus and this minus will cancel out, so it will be 1 over x minus 1 dx. So this will be 1 over x square, and then it is minus minus plus, and then this integral is log of x minus 1. Okay, and then this becomes 1 over x square into x minus 1, or x minus 1 over x square. So the value of u is x minus 1 over x square. So what will be the value of u, small u? Small u will be equal to capital U dx. So it is x minus 1 over x square dx. Then it will be equal to 1 over x minus 1 over x square dx, and then its integral will be log of x minus 1 over x square. Integral is plus 1 over x. So now we know that u, then we know that y2 is equal to u times y1. So u is now log x plus 1 over x times y1 is x. So it is x log x plus 1 y2. So it's the same answer which we got before, but in this case we had to perform much fewer calculations, much less calculations. Okay, let's do another example. Suppose y is equal to e power x is one solution for the equation y double prime minus y is equal to 0. So what is the second solution? So we can use the reduction of order process. Okay, so for reduction of order process, if we assume this is y1, then y2 will be equal to u2 times y1, or sorry, u times y1 and or u times e power x. Okay, so it will be then y2 prime will be equal to u e power x plus e power x u prime, or y2 double prime will be equal to u e power x plus e power x u prime, and then from here it will be e power x u double prime plus e power x u prime. So we can combine some of the terms. So for example, u, there is no u term, so u e power x, and then u prime e power x is 2 times, so it is 2 e power x u prime, and then e power x u double prime. Okay, so now we have these values. I can input these values into this equation. So I will put y double prime value is u e power x plus 2 e power x u prime plus e power x u double prime minus y. Y is this one. No, here u e power x minus u e power x equal to 0. So now this equation can be simplified. So u e power x cancels out. You can take e power x out. That means you can take e power x, you can remove it. So it will be 2u prime plus u double prime is equal to 0, or u double prime is equal to minus 2u prime. We can do a kind of like separation of variables. So now I can take substitution. V is equal to u prime, and then v prime is equal to u double prime. So inputting these values, u prime, then it will become v prime. V prime is equal to minus 2 v. So in this case, v prime over v is equal to minus 2, or in this case dv over v is equal to minus 2 dx. So in another word, if you integrate it, so it will be log of v equal to minus 2x, and v will be equal to v will be equal to e power minus 2x. So v was actually u prime. Yes, u prime is equal to e power minus 2x. So u will be equal to e prime minus e power minus 2x over 2. Or in other words, u was equal to u is equal to y u is equal to y2 over y, because u is equal to y2 over y1, okay, and y1 is e power x, okay. So u is equal to y2 over e power x, it is minus 1 by 2 e power minus 2x. So y2 will be equal to minus 1 by 2 e power minus, because e power x we take to that side, so it will be e and multiply by e power x, so it will be e power minus x. So generally speaking, if you take just minus 1 by 2 as a constant, so y2 is equal to e power minus x will be a second solution in this case. So same solution can be found by the capital U, those formulas which we applied for the previous case. Somehow you can say that we should not ignore the constants of integration. So for example, from here, if we have this equation dy over dv minus 2 dx, so where we encounter the integration constant first time, so it will be log of, if we integrate it, it will be log of v minus 2x plus integration constant c. Okay, so v will be equal to e power minus 2x plus c, so it will be equal to e power minus 2x into e power c. E power c we can take it as another constant which we call as c1 e power minus 2x. So now we know that v is equal to u prime is now c1 e power minus 2x. Okay, so from u prime we get u by the integration, so it will be minus 1 by 2 c1 e power minus 2x, okay, and then plus another constant c2. So from here, if we see that u is equal to y is equal to y2 is equal to u y1. So by inputting the value of u and y1, we get y2 is equal to this. So this can be regarded as a general solution of the given ordinary differential equations. It has both the terms minus x and plus x. So if you are